we are going to apply the loading on the foundation as well as on the columns. So first of all, we have to apply the load on the footing, that is subsoil first. So for that we have to choose this footing. So here it shows the first area, one area, and 4 edges are selected. Then go to the assign, go to the support data and soil property. If you have to click here, soil 1 is there. I am already assigned the property, you can check that. So here soil 1 is there, and the subgrade modulus is 3 into 10 to the power 4. Already I am assigned like this here. Okay, click on OK. Okay, it will show the property. Then we have to apply the loading on each and every columns. So initially we have to apply the loading on all the external columns, because the size of all external columns are 500 by 500 and remaining 4 are of 600 by 600. So for applying the loading, so click exactly at the center of the column, go to the assign, loading data, point load. Here the load pattern name is dead load and live load. 2 loads are there, so we have to apply 2 loads. So first dead load is there, we have to go to the gravity load. Here you can apply the gravity load, write the value, give the dimension, that is 500 by 500 here, 500 in the x direction, 500 in y direction, and click OK on that. After that again select the same point load, go to the assign, go to the load data, point load, live load, and put the value here for the live load. Same data is there, 500 by 500, and click on OK. That will assign the dead load as well as live load on the point load, on this column. So in such a way that each and every column we have to select twice and apply the dead load as well as live load. Similarly for this point load, that is the load on this column, here assign, load data, point load, dead load is there, you can put the value here, and here the size of load for punching here in x direction, here it is 600, and in y direction also 600 is there, and then apply this on it. So similar for the live load and dead load we are going to. So if you have to check whether we are applying the load or not, so you can click, right click here and go on the load. So here dead load is there, so which is applied in x direction here 1850, the size is 500 by 500, and live load is of 797.6 and size of 500 by 500. You can also check by this way. Then for this center hole, here the load is applied, dead load, and now the size is x in my direction is 600 here. For live load, this is live load on that column, and these are the sizes 600 by 600. Okay, so in such a way that we have to apply the loading on all the columns. After the loading, we have to assign the rebar material for the footing and for the column strips also. So for that purpose, we have to click on the right click on the footing, and here we have to go in the design. So here rebar material is there, HYSD 500. I am already applied here. So if it is not applied, so you can use here in such a way that you can go there. Okay, so click here, and this is for the footing. We are applied the rebar material. In the same way for the all column strip, that is, this is the first, second column strip, third column strip, fourth, then y direction 1, 2, this is third, and for fourth. So we have to check, right click on that, and here check design, here rebar material HYSD 500. I am already assigned here. Click on OK. So you can go at any strip, so you can check here. So all the horizontal layers or strips are in A group is there, and all the verticals are in B, column strip B is there, HYSD is there. Okay, so apply this rebar material to all the footing and the strips. Now we'll go for the analysis. So go to the run analysis. So as we have to done the analysis, so it will show the displacement value or deform the shape here. Now we will go to the run and analysis and design. So when it is completed, you have to check, go to the display, show punching shear design. So check here all the value for this ratio, bunching shear, capacity ratio or shear reinforcement. This ratio, it should be less than 1, it should not be more than 1. So all our columns are having the less value than the 1, because I am changing the dimension of the foundation. If any one column has more value than 1, then you have to go to unlock the model and go to the property and change the thickness of the slab. So initially I used the 900 mm thickness of foundation, so it fails because the value of this 4 column is more than 1. So I unlock the model and go to the define menu. In that define, so a property is here there, slab property. In that slab property, add foundation. Here the thickness of foundation I've changed from 900 to 1200 mm, and then done the run analysis and design. So I'll get this value. So this means that our mat foundation design, that is analysis and design, is successfully we are done. Thank you for watching.